All right. So here is our first function that we are going to graph. We've got x squared minus 9 over x squared minus 7x plus 12. We're going to find all the pieces here. We're going to need discontinuities. We're going to need intercepts. We're going to need all the things. So what do we need to do first? Factor. So before I can do anything else, I need to see if either of these numerator or denominator factors. So what is our numerator factor to? X plus 3, x minus 3. That's the difference of squares. How about our denominator? What does that factor to? Yeah. We have x minus 4, x minus 3. So do we have any discontinuities? Yes, because this piece will cancel out. So our remaining function, I'm going to put it up here. X plus 3, x minus 4. And our discontinuity is going to happen where? At x equals 3. Because it's whenever x minus 3 equals 0, that's where we get a problem. So our discontinuity happens when x equals 3. But when we're writing our discontinuities, we write them as points. So it's going to be 3, comma, how do I find my y? Substitute this piece in. So we're going to substitute in. So we have 3 plus 3. Substituting into our leftover bit up here, this guy. Over 3 minus 4. So we get 6 over negative 1, also known as negative 6. So our y is negative 6. So we have a removable discontinuity, a whole, at 3, negative 6. So then let's go over some intercepts. How am I going to find my x-intercept? So where is it going to be? Yeah, it's when our numerator equals 0. So when our x plus 3 equals 0. So our x-intercept is going to happen at negative 3. What's the y value for an x-intercept? 0. So negative 3, 0. It's going to be that guy. Where are we going to have a y-intercept? This is not going to be positive 4. It is not going to be 3, negative 4. It's going to be at 3 over negative 4. That's when we substitute 0 in for the x. So it's 0 plus 3 over 0 minus 4, which is negative 3/4. So our y-intercept happens at 0, negative 3/4. Substitute in 0 for our x.
Yeah, I think I need my master's.
Unfortunately, that is not enough for a master's in mathematics.
Oh, yeah, with the grade of this.
I was going to say, I am currently working on mine, and we're doing very strange things. What's up? Not positive 3 over 4? Because 0 minus 4 gives me a negative 4. 0 plus 3 is positive 3, so we have positive 3 over negative 4. It's the ratio of our constants. All right, so then let's look at our asymptotes. Our vertical asymptote How are we going to get our vertical asymptote? When our denominator is 0. So that's when our x minus 4 equals 0. So where is our vertical asymptote?
4.
X equals 4. So my vertical asymptote is at x equals 4. So we're going to have our vertical asymptote like this. My graph is so big. Oh my gosh. There we go. Where are we going to get our horizontal asymptote? I was going to say I heard a couple of different answers. What are our leading coefficients? 1 over 1. So our horizontal asymptote is at 1. Y equals 1. It's the ratio of those leading coefficients. What's up? Huh? Yes. I have a study guide. Yes. So we get our horizontal asymptote right here. And I have enough information to get one side of my graph for sure. Because I've got my discontinuity, I've got my y-intercept, I've got my x-intercept, and I know it's going to approach my asymptote. Like this. And it's got to approach this asymptote too. How can I figure out what I do on the other side? Pick a point. Any point. What is any point to the right of my asymptote? 5. So we need to find f of 5. That absolutely works. It's going to give me a point, and that'll show me exactly where my function will be. So you can use the original function, or we can use our simplified after our roots come out. So we're going to have our 5 plus 3 over 5 minus 4. So what is f of 5? 8. So when x is 5, my y is 8. And now I know kind of where we are. We're in the top right corner, so I can give myself a little sketchy sketch. So it's going to look kind of like that one. So we only really need to substitute in values if we can't figure out what's happening in a piece, in a section. So if we can't tell where our graph is going, we're going to pick points and substitute it in. And you can pick as many points as we need to find points all kinds of places. So, questions on the first one? Nah, I like it. Let's do another. Because we had some funky things. All right. What can we do first? It does not factor. It's worth a shot to check, but this one does not factor. So are we going to have any discontinuities? If it can't even factor? Nope. We're going to have no hole in here. In order for us to have a discontinuity, it has to have something that cancels out, which means it has to factor. So we have no discontinuities. So then how am I going to find my x-intercepts? That's y-intercept. So my x-intercept is usually when? Not when our denominator equals 0. That you're thinking asymptote. It's when our numerator is 0. So when will x squared plus 6x plus 1 equal 0? We don't know. Do we have a tool we could use to help us find out? Do we have something we could use to find out what its roots or solutions or zeros may be? We have a tool. Can do a square roots. The quadratic formula. Oh my gosh. Because our solution here is going to be x equals, help me fill it in,
That gave me a headache.
-6 plus or minus square root 36. So my b squared, that's 36 minus 4 times 1 times 1. So we're going to minus 4 all over 2. What's my a? 1. So I'm going to simplify this a little bit. So my x equals -6 plus or minus the square root of 32. Is that going to be a real number or an imaginary number? How do we know it's real? Because it's not a negative under my square root. So since we're sketching these, let's get a decimal version of that. Which, aren't you guys lucky we can use calculators instead of trying to do this as simplified radical? So we're going to need our plus and our minus. So what are my two solutions here? Decimal, give me like 2 decimal places. -0.47, 17. So you're typing it in the calculator to get decimals. Simplified radical form? It's going to be hard to graph then, because where is -6 plus square root of 32 over 2? .83. I just don't have the decimals written down on my paper, so I'm trusting you. Oh, seem right. They're in the right zones. So they're not pretty, but I know I'm going to have one somewhere here between 0 and -1. And I know I'm going to have an x-intercept over by -5, almost -6, so somewhere over here. So they're not pretty, they're irrational, but they exist, and they are going to be helpful when it comes time for plotting stuff. So how about our y-intercept? So we're going to have our... Yeah, it's going to be that 1/4. Oh, 0 and our -5.83. 0. Those are our x-intercepts. Our y-intercept, that's when we get our ratio of the constants, our 1/4, because we substitute in 0. So it's going to be 0, 1/4. So it's, again, fractiony and gross, but it's somewhere in there. Now we need some asymptotes. Our vertical asymptote. Yeah, our vertical asymptote, that's when our denominator equals 0, right? So we're going to have one at x equals -4. So we've got a vertical asymptote right here. What's our other asymptote going to be? Is it going to be horizontal or is it going to be slant? How do we know it's slant? Because the top has a higher degree than the bottom. When our numerator has a higher degree, that's when we need to do some division. That's how we get the equation for our slant asymptote. So since our numerator is a squared and our denominator is a linear, we have to divide it. So I'm going to do it with our synthetic division. We're taking our x squared plus 6x plus 1. So we're going to have our 1x squared, our 6x plus 1, and we're dividing it by x plus 4, so my root is -4. When we divide this, my 1 drops. 1 times -4 is -4. Add those together, we get 2, -8, and -7. Our remainder is irrelevant to what we're doing, but I don't like to leave things half finished. So what is the polynomial we get out of the end of this function as we're doing it? X plus 2. So this is 1x plus 2. So our end behavior asymptote, which is not horizontal, but it is an asymptote, is happening on the line y equals 1x plus 2. That's where we get those slant asymptotes from. So how am I graphing a line that looks like 1x plus 2? Started at 2, up 1 over 1, up 1 over 1. So when we do that, we're going to get an asymptote that looks kind of like that. So do we have enough information on here to be able to graph our function? I mean, I've got points and I've got asymptotes. Do I have at least one point on either side of my asymptotes? Yeah. So I've got my x and y intercepts over here, and we always approach our asymptotes. It's got to get close, so it's going to look like this. Get all the way out. So something like that. And in the other one, I do have a point on my left-hand side. Since we got our x-intercepts as decimals, I can see that. Otherwise, what you're going to have to do is pick a point over here, substitute it in, and plot that point. And so if you want more clarification on what your shape's doing, feel free to pick more x values to substitute in. But this is what our function looks like. This is what it looks like when we have those slant asymptotes. Yeah, we're just graphing the line 1x plus 2. So starting at our y-intercept, our b, mx plus b. There you go. I was going to say, I can tell you're overthinking it, but I just couldn't tell where we were. Okay. So slant asymptotes are a little bit awkward, especially when we don't get any, nice intercepts off of our numerator. But they just take practice. But questions on this one? Oh, we're good. Okay. Now let's do this one. This is our ickiest for the day. This is the ickiest one for the day. No, I didn't say it's the last. It said it's the ickiest. I'm not going to end this on the ickiest one, ideally. All right, so we have x over x squared minus x minus 2. So, can we factor either of these? Yeah, we can factor the denominator. So my numerator, we're going to have our x. What is my denominator in factored form? X minus 2 and x plus 1. So this means the same thing. Do I have anything that's going to simplify out? No. So do we have any discontinuities? Nope. We have no discontinuities. But it's important that we check. So we're just going to go down our list just like we would before. Our x-intercept it happens when our numerator is 0. So when is that? 0. And our y value for that is 0. So our x-intercept is at 0, 0. Where's our y-intercept? 0, 0. It's the same place. If 0, 0 is one of your pieces, it is the it is one of your x-intercepts at least. And it's also your y-intercept.
Wait, why isn't the y-intercept 0 over 2?
0 over -2. Simplify it. What is 0 divided by -2?
0.
Still 0. So it is still the ratio of my constants, but that's just still happening to be 0. So it follows that same rule. So then let's find some asymptotes. Our vertical asymptote happens when what? When the denominator equals 0. So where are we going to have vertical asymptotes? X equals 2 and x equals -1. So we have 2 vertical asymptotes. Which we have probably not seen before. Ooh, I don't think you do these in Algebra 2, in Honors Algebra 2. If you do, I'm incredibly impressed. So we have 2 vertical asymptotes, which means we are going to have 3 pieces of our graph. One on the left, one in between, and one on the right. So let's figure out our end behavior asymptote and see what's going to go on there. Where are we going to have our horizontal asymptote? Y equals 0. It's bottom heavy, meaning there's a bigger degree on the bottom. So that is always going to happen at y equals 0. Or you can think of it as the ratio of those leading coefficients, but I have 0x squareds in the numerator. So 0 over 1 is just 0. So we have a horizontal asymptote here. So when we have 2 vertical asymptotes like this, our horizontal asymptote really only affects the 2 outside pieces. That middle piece in between can cross an asymptote. So when we're in between, in this middle section, which I gotta get to my laser pointer, in this section here, it can cross asymptotes. It can go through that horizontal asymptote. That's why when we kind of introduced it, I called this our end behavior asymptote, because it really is only affecting our end behavior. It doesn't affect what's exactly in the middle. So our horizontal asymptote really doesn't affect what's right in the middle. And I erased my green dot too. There we go. We tend to draw it there, but it can cross it. So we're just going to have to be careful and look and see what's happening. So we need some more information before we can make this graph. Because I need some more points. I have a single point and lots of information that I don't know. So we're just going to have to pick things, substitute them in, and figure out what our points are. And you can use either form of our equation, but what are some points we should probably do? Yeah, I was going to say, I need at least some from each section. So we need f of, do I want to do f of 2? -2 would probably be helpful. We need to do something on that right-hand side and see where we are over there. So something like 3 or 4 would be a good idea. Do we know what the center looks like yet? No, so we should probably figure out what's going on in there. So we're probably going to need to do maybe 1. We might need to do more than that. So let's find those values first and start from there and see what we know. So when we do f of -2, what do we get? Well, -2 over -2 squared minus -2 minus 2. Double check that. Watch your signs. -2 squared or minus -2. So that's plus 2. So we're at 6 minus 2. So we have -2 over 4. So we have -1/2. So at -2, we're at -1/2. So be careful when we substitute these pieces in. When we do f of 3, what do we get? Ooh, 3/4. So f of 3 is 3/4. So now I can see just from one point in each of those sections alone, I can see what's going to happen because we know it has to approach these asymptotes for its end behavior. So I know this piece looks like this. And I know this piece is going to go like this. Oop, let me get that one a little bit bigger. There we go. But we still don't know what's happening in the middle. So let's figure that out. So what do we get for f of 1? Yeah, -1/2. So I've got that. Can I tell what it's doing yet?
No.
Not super awesome. Maybe it looks like a parabola. Maybe it looks like a cube. So when in doubt, substitute more pieces in. We can use calculators. You don't have to do it by hand. So you could do -1/2. You could do pieces on either side. When in doubt, find more points. The more points you have, sometimes the easier it is to see. So we're just going to plug and chug and find more points until we can see what's happening. So when we do that, what do we get? (1.5), we got -1.2, is that what you said?
5.
-1.5.
No, 1.2.
1.25. So still somewhere down here. So we can definitely see the right side of this is going down. This side's doing this. What is the left side of this doing? Try -1/2. Because we have our, if you do -1/2, what do we get? What's up? We get 2/5 if we do -1/2. So you can just type these in the calculator. If we do f of -1/2, we get +2/5. So -1/2 means we're going to be up here somewhere. So when in doubt, just keep picking points to find dots, because this is going to make something that's kind of vaguely cubic in between. So it's going to look something like this. So when you have more than one vertical asymptote, the middle piece can do anything it can think of. It could be parabolic, it could be cubic, it could be something in between. So when you have those two vertical asymptotes, just substitute pieces in until you can see what the heck is happening there. Okay, so just pick points on either side of your asymptotes to find values. Okay. Oh, I labeled 2 of them as 3. That was there. Okay. No, I told you we were going to have 4 graphs today. We've done 3. I was going to say, but this one was the hardest one.
This is my favorite.
But questions on this one?
This one's got more easy, like less complicated.
Okay. One more. One more graph. All right, so we have x squared plus x plus 3 over x plus 2. So will my numerator factor? No. So do we have any discontinuities? Nope. If it won't factor, we don't have discontinuities. That makes it easy for that bit. So let's look for our x-intercepts. Where are we going to get our x-intercepts? Yeah, since it doesn't factor, we're going to need to find the zeros of our numerator with our quadratic formula. So negative b, so negative 1 plus or minus the square root b squared, which is 1, minus 4 times a times c, 4 times 1 times 3, so 12, over 2a, which is 2. So we have negative 1 plus or minus the square root of, not just 11, negative 11. So do we have real x-intercepts? No. So we do not have any x-intercepts either. So if we get imaginary roots, we don't have x-intercepts. That's just how that is. How about y-intercept? What's it going to be? 3 over 2. So it's our 0, 3 over 2. That's when we substitute substitute 0 in for x, or it's our ratio of our constants. So we only have 1 point so far. We've got 0, 3 halves. How about vertical asymptote? X equals negative 2. So our vertical asymptote's over here at that negative 2. What are we going to do for our other asymptote? Are we horizontal or slant asymptote here? Slant, because I have a bigger degree on the top. So that means we need to do some division to get our end behavior asymptote. So we're going to divide our 1, 1, 3 by our negative 2. So our 1 drops, minus 2, minus 1, 2, 5. So what do we have as our A of the equation? Y equals 1x minus 1, x minus 1. However you want to word it is totally fine. It's 1x minus 1, and this remainder is irrelevant to what we're doing. That's where we're getting that from. It's the coefficients after we divide, 1x minus 1. So where am I going to start for my asymptote? Negative 1. How do I find my next point? Up 1 over 1. Plot up our asymptote. I'm just getting all the way up to the edge so I can use my line tool. So we're going to have an asymptote that looks like that. So I know a bit about my shape. I have 1 point and I have my asymptotes. I can get a piece of it. I know that when this purple point is going to approach my asymptote here, And it's got to approach this asymptote as well, so it's going to look kind of like that. Then we got to figure out what's happening on the left-hand side. So I'm going to pick a point and substitute it in. What point do you want to pick? -3. So let's do it. What's f of -3? You could do -5. You can do any point to the left of your asymptote. You can pick whatever point you want, and we don't have to pick the same one. What do you get when you substitute in a -3? Yeah, -9. So when x is -3, my y is -9, so it's way down here. So that means this guy is similarly shaped, kind of like a upside down V, but curvy. Okay. So, hang on a second. I'm double checking the homework real quick and seeing if there's a question like this, because I don't recall. There's one more kind of question they asked, but I don't recall if they actually like it. Okay. So with the rational functions, you guys can do all the pieces in there. Tomorrow is an e-learning day. You do need to join the Teams call. It's Microsoft Teams. The link is in Canvas. I'm sure you have practiced that in your other classes. How to get on it. There, it should be up there. The link is there. All that jazz. We are doing stuff on there. We're going to look at 4.6. 4.6 is review. It's an Algebra 2 concept. It is variation. But we're going to go through it. It is not super long. So we're going to do 4.6 tomorrow. If you, for some reason, can't make it to the Zoom call, I will get the video posted as quickly as I can. There's also one from last year that's up there. And honestly, it's something you could probably pick up by reading it. Like if you look in the book or the scan of the book. This one, 4.6, even though it's the last one in the section, it's just because it looks like a rational function. You guys can do it. Okay, chapter reviews. If you would like to start on those, I have them there right here. Pick it up on your way out. I am going to dodge because the swarm is about to happen.